Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right. Well, today we have with us Jorge Vasquez from Bolivia. And I saw your talk at Functional Scala. Was that last week? 2 weeks ago? When was that? I don't know.
Last week.
Time is all strange.
Yeah, it's last week. Yeah.
Yeah, last week, and just loved it. And so we'll talk about your talk in a little bit. But yeah, great to have you on. And let's start with you're in Bolivia. How did you get into Scala in Bolivia?
Oh well, yeah. That's an interesting story. It was some years ago. I think 2015. I was working in a company here in Bolivia using just Java. So we used Java 8 there, and we used plain Java. We didn't use any frameworks at all. The company had its own internal frameworks and communication protocols and things like that. It was a telco company.
Okay.
And
from scratch.
Everything from scratch. Yeah. We also did some C++ to interact with some very low-level libraries to interact with the 4G networks and that kind of stuff. And I remember one day my boss, who is also my friend and my teacher from university, he told me about Kotlin. So he started looking at Kotlin and told me, "Oh, this Kotlin language looks really nice. It seems like a better Java."
How long ago was that?
That was 2015. Yeah.
Oh, okay.
So
like
early,
6 years
pretty
ago.
early.
Yeah, it was the early
Kotlin.
years. Yeah.
Okay.
So I got interested and I started looking about Kotlin. And I don't remember at what moment, but I got to Scala. So I started seeing
Java
some
to
information.
Kotlin to Scala.
Yeah, I think it was, I actually didn't do anything with Kotlin. It was like I was starting reading articles, right? And I think there was one of the typical articles like comparing Kotlin with Scala, right? And that's how I got to know about Scala, because I've never heard about it before. And I started looking at Scala, and I saw there was some interesting things from functional programming, right? Like these typical functions: map, filter, fold.
Do you have a math background? Did you study math in school, or?
Yeah. Well, not math. I studied engineering, but in that during my career, I had a functional programming course. It was just one semester, and that was with Haskell. And I loved Haskell that time. And yeah, I remembered about those things I've learned, right? Like filter, map, fold left, fold right. And I saw everything of that was in Scala, right? So that was the most exciting moment for me. And I decided to learn more about Scala, and I left Kotlin aside. So I started looking at the courses from Odersky in Coursera, right? There was already the functional programming specialization. And that, after that, I started learning about akka.
Okay.
And so that's basically how everything started. Yeah.
Cool.
Yeah.
And were you doing this at that telco, or had you moved on to a different job, or?
Yeah, well, the telco just wanted to use Java. So after that, I changed.
Java has the map and filter and all that stuff now too. Java 8.
Yeah. Well, that's a very good point, right? Also, I liked about Java 8 that it included the lambda expressions, maps, filters.
But operations.
Yeah, but it was limited, right? So I wanted to do. Well, at that time, I knew something about functional programming, like the basics at university, but I always wondered how would it be doing a complete application using just functional programming.
Yeah.
And I realized Scala had more potential to do that than Java. Java was like with the streams API, you could do some nice stuff, right? Like instead of doing those for loops, you could do everything in one line with streams, right? So that was awesome, but it was very limited. And also I wanted to use more Scala because of akka initially, because in that telco company we had, The application had
Telco
to
and
be
are pretty well fit for each other.
yeah, it was pretty well fit, right? Because with plain Java, we had to use these very low level concurrency primitives,
Yeah.
right? Like logs and synchronized blocks, and it
Yeah.
was awful because
Yeah.
there were also deadlocks, right? It was impossible to eliminate deadlocks,
Yep.
and sometimes for example, the short messages system uh, stopped, right? And it was a deadlock.
Yeah.
And after that, debugging to see what happened to to so that deadlock happened, it was really difficult. And even worse, it was refactoring the code so the deadlock didn't happen anymore. So when I learned about akka, I thought, well, this is a lot better, right?
Yeah.
We should use Scala with akka. And yeah, but
So you
sadly that
didn't start with like Java Akka. You just went straight to Scala Akka.
yeah, I wanted to start with Scala akka because I thought it was nicer than in Java.
Yeah.
But well, I didn't have the opportunity to use akka in that company, and I left. I started working in another company here that works with US clients, and with that client, I started using Spark. So
Okay.
also,
Got further
I
into
learned
Scala with
about
Spark.
Spark before, yeah. But well, initially they were using PySpark, and but they also used Hive and HQL for their jobs on AWS,
Yeah.
and they decided to migrate to everything to Spark, but they were deciding if they should use the Python version or the Scala version. And I told them Scala, we should use Scala, please.
Yeah.
So
That's because you wanted to.
Yeah.
That wasn't necessarily the best choice for them.
yeah, and well, we did some research, right? I remember one person researched the Python version, one the Java version, and myself the Scala version. And at the end, it was pretty obvious that Scala was the best option in that case. So
Yeah.
we migrated everything to Spark in Scala. And well, that's when I got more opportunities to work more and more with Scala, with Spark, basically.
Nice.
And well, after that, I saw that there were these nice libraries to make Spark more type safe, right? Like Frameless
I
and
haven't seen those.
Quill.
I've only used Spark with the data frame API, which I was not very happy with the dynamic
Yeah, yeah,
of it.
yeah, and that was a problem for us also because well, everything compiles, right? But when the job runs, gives you runtime errors, so we had to be very careful. And I saw there was this frameless library,
I haven't looked
and
at Frameless. I'll have to check that out.
yeah, it's pretty interesting. It's backed by Shapeless.
Okay, yeah,
So yeah, it uses these ideas of generic types and things like that.
yeah,
And after that, I realized there was also Quill.
yeah,
So I saw one of these great presentations by Alexander Yoffe.
yeah.
And yeah, it was pretty motivating because always Alexander presents in a very motivating way, right?
He does, yeah.
So, yeah, so I got pretty
I love
excited about
Quill. I haven't used
Quill.
Quill with Spark, but I've used it with Postgres, and it just I love it. It's fantastic. And we had Alexander on a month or so ago, and yeah,
Yeah,
that's cool. So you like the experience of Quill with Spark, though?
yeah, it was really nice. And well, besides that, I started exploring myself about cats, cats effect, Scala Z. At that time, I didn't know about ZIO yet. So, well, I was trying to understand cats, all that functor hierarchy, right? And it was really hard to understand. It was really complicated.
Yeah,
So I remember at that time I decided, well, I think I'll go back to Haskell. I learned better about Haskell, and I think that will help me to understand better cats.
right. Yeah,
And yeah, so I started reading some books about Haskell, and with that I was able to understand better cats. But still, I couldn't see. I wanted to really see the light, right? Like the moment, the light moment when you see, oh, I can really apply functional programming in everything, right?
Yeah.
And I was just looking for more talks in YouTube and things like that. And that's when I started. I reached to one of John DeGoe's talks in YouTube, and it wasn't about ZIO. It was about pure script, I think. Yeah.
Oh, okay. Oh, yeah. I think I remember that one.
Yeah, and that was awesome, right? And I kept looking for more talks about from John because he explains very, very well. And that's when I got to know about ZIO. So I remember his talk, functional programming to the mean. No, it was to the max, I think. Well, I think that was in the ZIO presentation. I don't remember, but there was one of these presentations where he live transformed an imperative application to a functional application with ZIO.
Oh,
And
nice.
that's when I said, aha, finally I can see the light. I can see now
it
that,
makes sense.
yeah,
Now
I
I can
can use.
understand these ideas. I don't have to understand the monad hierarchy.
Yeah, exactly. That was my illumination moment.
Yeah.
So yeah, and since then, I think that was 2 years ago. Yeah, when
Nice.
I got to know about ZIO,
Nice. And now
that
you're
was
at
the moment.
the Scala C is the name of the company that you're at, and they're a Scala consulting company. Is that right?
Yeah, exactly. I work with Scala C, well, Scalac.
Scala. Okay.
Yeah. Well, it has. I think both pronunciations are okay. So some people say Scala C, other ones say Scalac. So there was never a consensus, I think,
Yeah.
around that. But I started working there last year on March. So that's when, well, I was on my previous job and I was working with Spark, Scala, right? But I thought, no, I really want to work with Scala, with ZIO, with functional programming. So I started looking for remote companies and I applied to some positions. And in that process, I remember I also saw a talk presented by one of the Scala developers. It was in YouTube. I think it was at Functional Scala 2019. Yeah, I think that it was there. And that's when I got to know about Scalac. And they mentioned there, we are hiring and we accept, we're fully remote company.
And you can work in
So,
ZIO.
and you can work in ZIO, right? So that's when I decided to apply. And yeah, thankfully I was able
Awesome.
to join them. And
Nice.
since then I'm working with them.
Well, that's cool.
Nice.
All from Bolivia.
Mhm.
Cool. Well, yeah. So I mentioned your talk from Functional Scala last week, and so let's dive into some about your talk. So you introduced something called smart types, but I think we should start with not smart types, but what is this problem that smart types solves? What's the underlying problem?
Yeah, definitely.
Oh yeah.
What's the pain point?
Yeah.
Yeah, well, the problem was the following: precise data modeling. So we have like this typical problem in applications, right? Like there are several problems, right? The typical one is, for example, you have a function that accepts an integer as a parameter, and you have to check every time, oh, is this integer positive or negative? If it's positive, do whatever it needs to be done, and if it's negative, draw an exception, for example,
Right.
or return an either, a left value of an either, for example. And you have to keep doing that every time, right? In your application, you have to make sure all the time that you are receiving valid data. So, well, there are good techniques in functional programming to solve that kind of problem. So one of those techniques is using smart constructors. So the idea of smart constructors is that you make the default, for example, you have a name class which encapsulates just a string, right? And well, the normal constructor will accept just any string. It can be empty. It doesn't make any checkings. So the idea of smart constructors is that in Scala you can make the default constructor private, and you can create your own constructor in the companion object of this name class.
With
right?
your constraints applied on
With
the
your constraints applied, right? So you receive
You
an
can't
input
even
string.
have it won't create invalid objects. So if you think of a type as a set of values,
Exactly.
then this makes sure that whatever type you create does actually fit in that set of values.
Yeah, and
Exactly.
So the problem that we're trying to solve is that we've got these base types that we store stuff in memory with, strings and integers, but for data modeling we want to have constraints that are beyond just those storage types.
But this also sounds like, I always forget the name of this kind of programming, the one where it's like, oh, I don't just specify this is an array of characters, but it is also size 10. You have the extra constraints that the language imposes.
Right.
What's that called? That's, they have a language for it or something. We've talked about this.
I don't know.
Okay, anyway, it doesn't matter.
Okay, so that's the general problem that we're trying to solve.
Right.
And so one approach that you can take is to have a smart constructor, which is going to, I guess, in the very basic form, non-functional, you would throw an exception if you try to construct this thing and you violated.
But that would be at the point of trying to create the object in the first place.
That's right.
Rather than waiting till you're trying to pass it into.
Exactly.
You'd say, okay, it's got to be this type.
That's true. And I guess maybe a more traditional approach is to not validate until you try to pass it into something that uses it. And to have more precise data modeling, as Jorge framed this, the precise data modeling, your function does not accept something that is invalid. So your type parameter to your function expresses the valid type that you can give it.
Right. And if it's got to be in the range from 0 to 10, then it's going to say, okay, because it's that type, I know that it will never be outside of that range.
Yeah.
Rather than checking it inside every single function.
That's right.
Okay. So that's
you would have a type that says that says, I don't know, a really bad name would be integer 0 to 10 or something like that, but you would have a type with that name.
Exactly.
Yeah, exactly. So if you have a function that receives this integer 1 to 10 type, for example, you are sure that the value is between 1 and 10, right? So that's the idea of these smart constructors, and it's a very simple technique that can be used in Scala and in other languages, not just Scala, because it's just a technique, right? And
so oftentimes the return type of your smart constructor isn't your value; it's either an error or your value, and then you have to then.
So you have to have a separate function and not a constructor, because a constructor doesn't have a return type.
In Scala, a constructor is just a function.
Oh, okay.
Yeah, exactly. So you can have this smart constructor function that will return this either type, for example. So it will be either an error or the type like that you want, like name, for example, right? So that's the basic idea that we can use in Scala for data modeling, and it works very well, but it has some limitations. So, for example, if you try to, the example I've shown in the presentation at Functional Scala was a more complicated one. Let's say we have a person class, and this person has 3 fields: name, email, and address. And the most naive implementation of that would be modeling everything as strings, right? And that
name
gives
is a
us
string, email is a string, address is a string.
Exactly, and that's like
no constraints possible
no constraints, right? And that gives us several problems. One, that we don't have validated data, and the other problem is that we can mix up things, right? We can mess up. So when we try to instantiate a person, we by accident we can pass an email to the name field, for example. And because all of them are strings, the compiler won't help you so you know that you are making a mistake there, right? So
Compiler
that's a
just
problem.
says, "Great,
Well,
you gave me a string," and
the type of string is anything. Can it be null in Scala?
string. I think technically you probably could pass null.
Yeah,
So,
you could pass null, yeah, but
okay,
well,
so
in
empty
functional programming
string,
we restrict.
super long string. Yeah, it's just a string, no other type restrictions on it.
Yeah,
Exactly, it's just a string, right? And well, with this technique of smart constructors, we can create our custom types, right? Like name, email, and address that inside of them encapsulate the strings, but these custom types have these smart constructors that will do some validations and so on. And now that we have these custom types, it's impossible, for example, to make that kind of mistakes like you passing an email to a name, right? The compiler will yell at you and tell you that that's not the thing to do, right?
Right.
yeah.
Right.
Be like, oh, you tried to put an email in the name field. That's not valid. And then you
Exactly.
also can, with the smart constructor, do some validation, like
Does
name
it have an
shouldn't be
at
an
sign?
empty. Yeah, there should be an at sign in the whatever regex
Email,
thing you
yeah.
want to do to validate that it's an email.
Yeah, so
Exactly.
you simply never create a person that isn't valid.
That's
Exactly. So
That should be fundamental.
make
yeah, I think
unrepresentable states. No, what's the hash?
yeah,
Make
I
unrepresentable states impossible, or
Yeah,
something like that.
make invalid states unrepresentable.
Right.
exactly. I was remembering about a talk by Richard Feldman. I've seen you invited him some weeks
Yes,
ago.
yeah, we talked to
We
him a couple
interviewed
weeks
him.
ago.
Yeah, and he had one of his talks was precisely about this subject, right? It was in Elm, but it was the same idea: make impossible states unrepresentable, right?
Yeah.
So that's the idea. Yeah, and it's a very basic one, right? But it's so obvious that that I think we don't remember it, right? So we have to be conscious about using it, and it solves a lot of problems just by using this technique.
Yeah.
But
It's just that sometimes the ergonomics of doing your data modeling in this way is hard. and we'll get into some things that you've done to make it not hard. But I
exactly.
think that's really, I think probably most people could get on board with the idea, but sometimes it's just is hard to do that well.
Well, I think it also, I mean, in my own head, I keep asking, oh, what is a type? And then I come back to this mathematical description of it's a set of values. And at first I didn't like that. It was too mathy. But now I'm going, oh, now we have the basic idea. And how do we get to those set of values? So one way is the smart constructor. And after you explain it, I'm going, well, that sounds like the right solution. Why is that a problem?
Okay, so one of the challenges with this approach is that if you have a smart constructor that returns an either for your name, for your email, for your address, and for your person, the code that you have to put together to do all of those things and assemble it all together and maybe accrue all of your possible validation errors, like it just gets nasty.
Isn't this just a functional composition issue? Is
that what
you're doing?
It's just that the ergonomics of it can be really painful.
Because I would like to know if the name field is wrong and there's only one name in the name field. And is the email address wrong? And I don't want to have to go back again and again to get that information. I would like all that information at once. So is that the problem?
Yeah, exactly. So before to create a person, for example, if you had just the strings, to create a person, you just needed to pass the strings and that was it, right? But now we can't just pass a name or an email or an address directly because the smart constructor always returns an either of those types, right? So now we have a new problem that's composing the eithers, right? And well, in Scala, we can use for comprehensions to simplify that that composition, right? Because without for comprehensions, it will be a lot harder, right? But it's still something that it's unpleasant, at least, right? So
the for comprehension is going to just fail on first error when maybe you want to aggregate all of the errors.
Well, exactly. Maybe you want to aggregate all the errors, or maybe you are creating data with constant values, right? Like you are trying to create a person, I don't know, James Ward with James Ward at .email.com and with a valid address. You know the
So
data
at
is valid.
compile time, you have
At compile
static.
time,
Yeah,
you
you
know.
have static values, and so
Okay.
you don't want to have to go through all the messiness. You're like, I know this is valid. Like, don't make me have to go through all the either, for comprehension, whatever it is stuff. It's like, this is a valid person, and I know it is, and you can trust it because at compile time I have these values. But in
Exactly.
the case of the smart constructor, it doesn't matter. The smart constructor doesn't care if it's runtime or compile time, and so it's painful when you know that something is valid. At compile time, there's
No, the smart constructor is only run at runtime, right?
That's right, exactly.
Okay, so
That's why the
at
smart
compile time you
constructor
don't
is.
get that.
Yeah.
You don't. So what you want to do is be able to create static values and have them checked at compile time.
We'll
Exactly.
get there. We'll
Whoa.
get there. But before we
Okay.
do, there's a couple other challenges around this idea. One is how is your type actually stored? Do you use a case class in Scala? And if so, then you have wrapping around that primitive value, and so you've got more memory overhead.
Okay.
So alternatively, you could use a type alias to a string, but then there's all these ergonomic issues with that approach. And Jorge, you can tell us, this is, I think, part of your presentation, so you can tell us about some of the ergonomic issues with type aliases, and then you could also tell us about opaque types.
Okay.
Yeah, because well, you've mentioned other problem, right? Like, well, this first problem, like it's like extra boilerplate, right? When we know data at compile time, but the compiler can't check it, right? So that's one problem with smart constructors. And the other problem is runtime overhead, right? Because we are using case classes that wrap these strings, right? So we have additional boxing and unboxing overhead at runtime. So that's the other problem, right? We could use type aliases instead of case classes. But so you could say this type name equals a string, type address equals a string, type email equals a string. But with that, we will have the same problem as before, in which you could mix up your parameters when creating a person, right? Because
With a
at
type
the end,
alias, you can give it a string, and the compiler
yeah,
is like, cool, an email is a string and a name is a string. So
So you've lost
you've
your
lost
type
your
information.
yeah
you've lost your type information, right? Type aliases
your
are
type
just other
constraints.
names for the same type. They are not separate types, right?
Mhm.
So those are the problems with smart constructors. So in the presentation, then I explored other techniques that we could use instead of smart constructors to solve these problems. So the problems are the compile time boilerplate, unnecessary boilerplate, and the other problem is the runtime overhead, right? And also we have other boilerplate problem at compile time, that is, if you know that you're trying to create data that is invalid at compile time, the compiler also won't detect that, and it will construct eiters. Ideally, we would like that to give us a compilation error, right? So smart constructors done that for you,
Yeah.
right?
Where I experience this challenge a lot is when writing tests. So when I write a test, like ideally my constraints that I have on a type would cause compile errors if I've violated them. And then likewise, if I don't want to use a smart constructor in my test because I know what data I want to pass this thing and I know if it's valid or not. And so when you're writing your tests around these more precise data modeling types, it can be a huge pain for a lot of reasons.
Exactly. And well, so exploring other techniques. For example, there is this new type library that works just in Scala 2, by the way. It doesn't work in Scala 3. And I don't know if they are going to create a version for Scala 3 because maybe it's not even necessary for Scala 3. So the idea of this new type library is that you can still use this nice smart constructors technique, but you can annotate your class with this new type annotation. And the effect of that is that the runtime overhead won't be there anymore. So at runtime, these values will behave just as normal strings. They won't be boxed inside these classes like name, email, and address. At compile time, yes, but at runtime, they will be simply strings.
So is it using macros to do that?
Yeah, I think it uses macros under the
Okay.
hood to achieve that, right?
Okay.
So
And it's kind of a weird syntax. Like, there's a couple different libraries that I've used around this, and one of the things that's challenging in this space is that I've seen a bunch of different names to describe this same concept.
Mhm.
So there's like new types, and then there's like tagged types or tagged unions.
yeah, there are several names.
Yeah. And so it gets a little confusing to know like that all these things are really trying to solve that problem of precise data modeling. And in Scala, there's a number of different libraries that you can use for it. So new types is one.
Even the phrase precise data modeling doesn't actually tell me what the problem is.
Yeah.
It just says, yeah, it's kind of generic. So
Yeah.
Need
a better
a
name.
different term. Yeah.
Well, smart types.
Smart types, maybe. Yeah, actually, that is more. At least opens my brain up a little more than precise data modeling. We could be talking about domain-driven design or something.
Yeah.
Yeah. So
True.
anyway,
So the new types approach, we have better runtime performance. Like we don't have the overhead of the boxing and all that, but we don't get the compile time of static values
Exactly.
checking. Like that's one of the downsides of that approach, right?
Yeah, we have the same problem as before. So if we try to create data that we know it's valid or invalid at compile time, the compiler won't detect that. So we'll have the same overhead with either and for comprehensions and things like that. So
Well, and ideally you want to have some way to express your type constraints, and potentially express multiple type constraints. Like
in kind of a mathematical way.
yeah, you want to be able to say like must be longer than this on a string, or must be,
Must contain these characters.
Must contain these characters, and you want to be able to have multiple. And I don't think new types has a good way to express those kind of constraints.
It doesn't have. Yeah, and in fact, that's a problem I didn't mention in the presentation, and it's a very good one, because when you start using this smart constructors technique, for example, with or without new type, the problem is that you have a lot of duplication, right? Because, for example, in this very simple example of the person class, you have name and address that basically have the same constraint, that is they shouldn't be empty, right?
Mm-hmm.
And you have to write that logic for each type, right? For each smart constructor, you have to rewrite that same logic. So that's also a little painful, right? And with new types, it's the same thing, right? Because in new types, you also write your smart constructors. The only difference is that it's the only difference is that you add this new type annotation to eliminate the boilerplate at runtime, right? But yeah, so that's another
new types are
very
kind of
important
like
limitation.
the type aliases, but not they don't let us pass a email to a name field. Is that right? Is that one of the main differences between type aliases and new types?
Yeah, exactly. Yeah, and well, actually, at the very basics, this idea of new types comes from Haskell, right? So in Haskell, for example, if you try to create the equivalent to a case class, will be creating a data type. You have this data keyword, and you can create like this name type with a string inside of it. But that means additional boxing, right? But if instead of using the data keyword, you use the new type keyword, that tells Haskell to treat that type as just a string at runtime. And that's the basic idea of new
you
types.
get a name that is not string for it.
Yeah, exactly. So that's the basic idea, right? And well, after that, you can add these smart constructors and things like that, right? So well, new type solves one problem, but not the runtime problem. But the compile time it's still a little ugly yet. So if you try to convince your teammates, right, it's a little hard because they don't understand, why I have to keep this repetition across all these types, right? And I need to use either everywhere and this for comprehension. So it's not very convenient. So I export other library in Scala that's refined. And refined is a very interesting library. It also just works in Scala 2 for now. And it's inspired in Haskell as well, as I know, as far as I know.
Okay.
And the idea of it is that you can define type constraints, but at the type level. So it uses
There's like a DSL. There's like a type DSL, like
a type level DSL, exactly.
So in your brackets, you actually use types to convey the constraints that you want to apply to this thing, and so it's a very, very kind of strange, awkward DSL.
Yeah, it's a little hard to use, right? And well, now in Scala 2.13, it's a little better when you try it. For example, if you want to define your email type, normally you would just create a type alias, right? And say this type email equals to a string, a refined string that must match these regex. But all of that you have to write as a type. So it has a type syntax. And before Scala
Not the
2.13,
normal Scala syntax that you would write this in.
yeah, the DSL was a little weird because being able to write the regex, for example, that has to be matched, you had to write this W and T at the beginning, at the end of the regex. It was weird looking. So yeah, it was
some
really
amazing tricks with the type system to be able to do
yeah.
it. But you look at the code and you're like, how is that even valid Scala code? It's
I have
wild.
used regular expressions for decades, and I only get to a certain level of complexity before, well, usually what I do is break it down into multiple regular expressions because one of them is too complicated.
Yeah.
And even then, if I go back and look at it after any amount of time, I don't know what it.
So now combine that with trying to express that regex in a type system.
Yeah.
In the type, not in.
I don't even know what that means.
Not in a string. I know.
I can't imagine it. So
yeah, it's very weird. And in Scala 2.13, it's a little better because now to include the regex at the type level, you don't need to use this W and T that you need to use before, because now Scala 2.13 has singleton types, right? So that's why the DSL improved a little bit there in Refined, but it's still a little awkward. But the advantage of Refined is that, for example, if you have this email type, you have a type alias email equals this refined string that matches this regex. To create, for example, an email at compile time, you can do that, and the compiler will detect if the email you're trying to pass is valid or invalid. So you could say val email equals, and you put a valid email there, the compilation will work okay. And if you pass, for example, an empty string, the compilation will fail. And it will tell you this value doesn't match these regex. So now the compiler is able to detect errors at compile time. So that's awesome about Refine.
It gives you the benefits of being able to use the same validation at compile time and at runtime. And in the case of runtime, you get back an either, whereas at compile time, you get back just the value. Right?
Well, and in the evolution of all of these things, I can see that it would also demonstrate that this is a valuable thing to do, to validate at compile time.
Yeah, exactly. Yeah. And well, as James was mentioning, Refined has this refine V method to do the same refinements, but at runtime, right? So you have compilation, validation at compile time and at runtime. So that's awesome, right? So that's a problem that's solved there. But
are they boxed though?
They aren't boxed, so
okay.
They don't introduce any runtime overhead. But there is another problem now. Well, it's like a problem we already mentioned before. If you just use type aliases, for example, you have this name type equals refined string non-empty, and you do the same for address, you have the same problem as before, right? You can intermix address and name by accident, right? So we have the same problem again. So the way to eliminate that problem will be combining refined with smart constructors. So that way you have compile time validation and runtime validation, but because we are introducing smart constructors again with case classes, that means boxing, additional boxing again at runtime, right?
Who did
So
that?
yeah, so it seems there's no way out, right? So that was the problem we were trying to solve in ZIO Prelude, right? So the problem is that, well, you have to choose your poison, right? What do you prefer? Extra runtime overhead, or do you want to live with extra compile time overhead? You can solve both problems at the same time. So that
before
was the
this, there
thing.
was no way to like have our cake and eat it too with all the things that we want from precise data modeling. So it just didn't exist.
It seems so fundamental. Once you start talking about it, it's because like, okay, we have types that the compiler will check, but then we have the creation of these types and whether they're valid or not, and that seems so essential to what we're doing.
Yeah. I mean, ideally, you would in a program almost never use primitive types like string and
Right.
int and whatever. Like
Sure.
everything would be a more specific.
But then
type
there's the
that,
boxing issue. There's the efficiency issue, and
or
that's
the smart
always
constructors
maybe
issues.
for 80% of the people using the boxed is fine. But then there's always going to be the others who go, it's this is going to cause us problems, and so you have to solve that problem. But it really seems like this should be part of the language. And as I'm slowly learning ZIO, one of the things that I kept asking was, what is ZIO? And finally, I think it was Kit, because I said, this feels like more of a language within a language. And he said, yeah. And this is part of that.
Yeah.
What you're doing is part of that.
Yeah.
Is like, okay, now our new language here's how you create things and make sure that they're reliable without. So how do you solve the problem of boxing?
Yeah, well, that was interesting, right? And well, before going to ZIO Prelude,
oh yeah, we got to do
you
opaque types.
Oh, okay.
Yeah, you could think, well, Scala 3 now has opaque types. Maybe with opaque types, all the problems are solved, right? So the idea of opaque types is it's basically they are type aliases, right? But they are more smart. So you can say opaque type name equals a string, right? So in every part of your application, the compiler won't know that under the hood this name is a string. It's a type alias, but all your application doesn't know about that. It thinks it's a different type.
Yeah, you can't accidentally intermix a string.
You can't intermix strings with names.
Aliases.
So it's kind of a fix to type aliases.
It's a better type alias.
Okay.
It's a better type alias, exactly, right? But you don't, if you want to add these additional validations, right? Like, well, this name's a string, but it has to be a non-empty string. You again have to resort to smart constructors, right? And
Eithers
and boxing.
And you have the eithers.
No compile time validate checking of values.
Exactly. So again, we have the same problem. So yeah, it seemed there wasn't any way out. So that's why we started looking. Well, this was John's idea originally, and he told me, well, maybe it would be nice to implement this. Well, by the way, I'm part of the Spartan program of John, and yeah, we have these one-on-ones every month, and you can use that time as you wish, right?
So he's mentoring you, and your project that you're working on with him is
exactly. So that's awesome. Yeah, because John knows a lot about Scala and functional programming, and at that time I remember I wanted to explore more Scala 3 macros because Scala 3 wasn't even released yet. It was almost there. And every one of us knew about these new and shiny Scala 3 macros. I saw the Alexander Yoffe presentations again. He put some nice videos in YouTube, like implementing a very basic version of Quill in Scala 3 to demonstrate how Scala 3 macros work. And I told John, well, I'd like to explore more about these Scala 3 macros thing because they seem really, really cool, right? And he told me, well, maybe we can implement these. Well, we told them refined types at that time. They weren't smart types. And the idea would be that they should be validated at compile time and at runtime, and there shouldn't be any overhead. So that was the goal. John had the vision initially. He had the idea in his mind.
So good ergonomics, good efficiency, good compile time validation.
Ideally,
like
understandable.
Understandable.
Understandable. That
you want to be able to write your constraints in a rational way, not
yeah. So
parameter.
like keep like I think when you were talking with Kit some time ago, you mentioned, right, like ZIO is like a state of mind, right? And I think this state of mind is making everything as performant as possible and as ergonomic as possible, right?
Yeah.
Because that's how we are going to attract more people to functional programming, right? And so those were the objectives, and we started exploring first how to implement these smart types in Scala 3, because that was my initial objective. And well, it was a little difficult because there is not too much organized documentation around macros, right? After talking these really great talks from Alexander, I started to understand better macros, and I was able to implement something very basic. And after several weeks, because we weren't being able to implement what we wanted, finally worked. So the idea was that we should have this nice assertion DSL. And this assertion DSL, it's basically where you say, this has to be a non-empty string, for example, or this number has to be greater than 0 and less than 100. So we have a nice
assertions.
Yeah, we have a nice DSL for assertions, but we wanted those assertions to be evaluated at compile time. So that was the problem, right? And how to do that with macros.
Because the assertions are written in Scala, right? Like they're
written in
normal
Scala.
code.
It's normal Scala code.
Yeah. So how do you take something that is a Scala runtime thing and make it run at compile time?
Exactly. So that was the problem, right? And well, that's basically what Quill does, right? It has an DSL that normally would be executed at runtime, but with the magic of Quill, everything is evaluated at compile time, right? So that's how we get we have a normal Scala expression converted to a SQL query, right? So, but I didn't know how to do that, right? I didn't have all the knowledge that Alexander has, right? So well, but after looking at his talks, everything was clearer, and we were able to implement the basic version, and it worked. So that was really exciting. And well, after that, the next challenge was, okay, now we would like to make it work in Scala 2 as well. Maybe it's not possible. We didn't even know if it was possible because Scala 2 macros are completely different, right, from Scala 3 macros, and they are harder than in Scala 3. And Kit was the one who helped me there a lot. So, but because he has more experience in Scala 2 macros than myself, right, because he has worked a lot in improving ZIO ergonomics by implementing macros under the hood, right, like he has improved the assertion DSL for ZIO test, right, so under the hood that uses macros. So Kit helped me with that, and he made it work in Scala 2. So that was awesome.
Yeah.
And after that, we integrated both versions, and we tried to make the syntax the most similar possible between Scala 2 and in Scala 3, because in Scala 3 there are some differences in the syntax, but they are very minimal, and that's because of how Scala 3 macros are different in Scala 3, right? But and well, finally Kit and Adam did some improvements there, because before implementing these refined types, that was the initial name, there was also these smart types, but they were a separate thing that John already had implemented before in ZIO Prelude, but it just worked at runtime. It didn't make any validations at compile time. Okay. So it eliminated the runtime overhead. That was the idea.
But one thing to point out real quick too is you also made it work so that when your underlying type is like a string, a primitive type, you made it so that your smart types don't have to be boxed, but you can use like a case class as well. So our example of a person is a case class which has boxing, but then the name, email, and address are just strings, and so those are not boxed. So you're able to then also unify this so that where you use a case class, it works, and where you use a primitive, it works.
Yeah, exactly. So yes, you have mentioned these smart types aren't boxed, right? So at runtime they will be just strings, right? And they do compile time validation, right? Thanks to the implementation with macros, right? So you can, if you want to create a valid person at compile time, you can do that directly without using either and stuff like that,
smart
right?
constructors, yeah.
Yeah, and if you want to do runtime validations, you can still do that, right? With either. Well, actually, not either. In the ZIO Prelude version, we use a better type than either. That's validation, right? So this validation, it's kind of similar to either, but it's not short-circuiting, right? So before we were saying that if we're trying to create a person with name, email, address, and the name fails, everything will immediately fail, and we will just get the error with the name, right? But with validation, you can validate all the fields in parallel and accumulate all the errors. So it's better than either.
It's an applicative instead of.
It's an applicative, right? So, so that's the fancy term.
I bring that up because Bruce and I were talking about applicatives a couple days ago.
Yeah, I probably understood it at the time, but now it's gone.
Yeah, just still accumulation. It has the ability to accumulate the errors.
That makes sense. So the thing is, this doesn't sound ZIO specific, but it's part of the ZIO library. So
ZIO Prelude, yeah.
Yeah, it seems like this maybe should be something that's just a separate thing that people can use without bringing all of ZIO in.
Yeah. Well, in fact, there was a discussion around that some time ago, and I've seen some people were precisely mentioning this topic these days in Twitter. And well, ZIO Prelude is a separate library, right? But it depends on ZIO, right? And well, the reason for that, I think, is that in ZIO Prelude there are, for example, ZIO Prelude besides smart types has other things, right? Like type classes, right? And in ZIO Prelude there are instances of these type classes for the types in the ZIO library, right? And that's why there is this dependency. But there was this discussion that maybe in the future this functionality of new types may be separated to a completely different library, not ZIO Prelude. So maybe that will happen. I don't know. But yeah, there was a discussion.
And then ZIO smart types.
Maybe Scala 4 will have this built in.
That would be nice.
Yeah,
that would be great.
So essential. You know, the more I think about just types in general.
Yeah, it's like what are your types for? You know, they should be there to help you.
Yeah, exactly. You should be able. Well, I sometimes we mention these typical examples about functional programming, right? Like, for example, if you have this division function that just divides to integers, is that pure or not? A typical function around functional programming, right? And you say, well, it's not, because if you try to divide by 0, it will throw an exception, right? So in that case, what do you do to make it pure? So you have two options, right? One option, it's like the typical one. Instead of returning int, you can return an option of int, for example, right? But the other option,
So anytime you do a division, you have to return an option and then unwrap the option, and it's
unwrap the option, right? It's
that
really
seems so
painful, right?
painful.
But the other option is using, for example, these smart types in the inputs, right? So instead of accepting two integers, you say, well, the first integer can be any integer, but the second one is an integer
A
not equal
non-zero.
to zero, non-zero,
Yeah.
right? So that way you can still return integer as a result, and you don't have this overhead of the option, right? Having to check the option value every time, right?
It
So
becomes a pure function.
and becomes a pure function, right?
Total function.
Total function, exactly.
Right.
Yeah.
Or your option 3 is when you divide by 0, just return 0, which Flix does this.
That, yeah, which
and
is a
I'm
little
so annoyed by this.
Well,
but
maybe we just don't understand it.
Yeah, there has been a lot of debate around.
Has there?
Because I think Rust maybe does the same thing.
Does it? Oh, yeah. Maybe
And
they were inspired by
there's
that.
been a lot of debate around whether or not this is the right thing to do, and I think the right thing to do is to make your divisor a non-zero guaranteed.
Yeah,
Just
exactly.
don't
Let the compiler help you, right? Because
Exactly.
well, the other option will be maybe not returning 0 in that case, but returning like the minimum value of int, right? And you have to be very careful about that, right? You have to remember that all the time, right? That you are
And then you
considering.
make the user have to check, right?
Well, you might as well just program in C if you're going to do that.
Yeah, exactly, right? So we are not using there the power of the Scala compiler, right? It doesn't make too much sense. So yeah, and well, I wanted to mention also these nice DSLs we have for assertions. They follow functional principles, so they are very composable.
Compose them.
You can you can compose assertions every way you want, and we also have this custom rejects DSL. So when you try to validate your emails, for example, you can still say it has to match these regex and pass the regex string, or you can use the regex DSL that it's nicer looking.
Yeah, I think you'd like the regex DSL because then you're not writing just a string regex. You actually have a type DSL that
Well,
it's a type
write
DSL.
your
and would it
regex.
give you more specific errors as well? Would it tell you like maybe where it failed? Oh, you're missing an @ sign or something.
Yeah, well, that right
could.
now, that doesn't happen, right? But it could. Yeah, I think that will be a very nice improvement. That the error messages will be more precise.
Good error messages out of regexes. That would be
awesome. That would be something.
Yeah, and the assertion library is really cool because I don't know if you've used like a combinator library where you chain together like in this case assertions, but the way that you chain them together is essentially building like an AST of what needs to be validated. So you can say like, all right, let's group these two assertions and both of these need to pass, but then you can say, okay, and so you can use like algebraic combinations of these different assertions, and you can use them across different smart types, so you can reuse your assertions as well.
Exactly.
So a lot of super cool stuff there.
Wow.
I have not used your new smart type stuff yet, and it is high on my list. Next week in our book writing session, we should explore this because I think we need a chapter in our book on smart types.
And I've been thinking a lot about how you compose data types in functional programming, so this would fit.
I think this feature will be it's really nice to include in applications, right? It solves both problems we had with the other approaches, the other libraries, and it works in Scala 2 and in Scala 3. So that's great. We really wanted to make it work in Scala 2 because for several years, there will be lots of projects that will keep using Scala 2, right?
For sure.
So we didn't know if this was going to work in Scala 2 initially. But yeah, thankfully it works in Scala 2 as well. So that's awesome. So
yeah, I mean, just coming from the Python world where we went from Python 2 to Python 3, it is a slog, and there's going to be a lot
Takes
of people who
many
drag their
years.
heels
Yeah.
and all that kind of stuff. So making it work in Scala 2, I can see how you'd go, I don't know if this is going to work, but it does. That's going to make a big difference. I think people will adopt it.
Yeah, exactly. Yeah, so I think that was very important, and yeah, it will help with adoption, right? So there is
For sure.
so if you use Scala 2, okay, you still can use it. And the good thing is that, as I've mentioned before, the syntax is very similar. There are some
And Scala
just,
2 and Scala 3. Yeah.
I think, one or two details that are different between the Scala 2 and the Scala 3 versions.
Yeah, because
But
maintenance is, that's the thing you got to look at. It's like, oh,
Right.
if we're going to maintain it for Scala 2 and Scala 3, oh, we got to make that as easy as possible.
Yeah. Make upgradability easy. Cool. Well, what else? Did we miss anything awesome about smart types?
well, I think that's basically it. That's the idea behind smart types. And well, there are still lots of improvements to do, right? Like having these more precise error messages. That will be great, I think. That will improve also ergonomics. That's something very important in ZIO. And well, we still need to add, for example, more assertions. And well, maybe there will be even more improvements on that side. And maybe I was thinking the other day, maybe we don't even need an assertion DSL, and we can use just plain Scala syntax to write the assertions. I don't know. I'm just thinking out loud.
Sure.
But maybe it will be similar to what Kit did in ZIO test, right? Like you can write your assertions just normal Boolean expressions, and they get analyzed under the hood by macros. So I think that's a possibility as well to make
Wow.
this even better.
That's cool.
That would be amazing. I mean, it all, yeah. I mean, for me, the more I think about types being, data structures being immutable, then you go, well, okay, so you don't have methods anymore, but you still have the construction problem. And that's where you need to put all of your smarts so that once it's created, you don't have to think about it anymore.
Yeah.
Yeah, exactly. You
That's
can
the
forget
thing.
about that completely, right? Because
Right.
in every part of your application, you know that if you receive a person, it's a valid person. It's impossible that it's invalid, right?
And
So you
suddenly a
know
whole
that.
bunch of logic just goes away. You don't have
Yeah,
to.
you don't have to check if the name of this person is non-empty and if the age of this person is I don't know, non-negative, and that's typical, right? In
Well, right, and
applications
it's a
that
dumb use of your time if you think about it. You're going, I have to duplicate this testing code in every single function that uses this thing.
Huge source of bugs
It's
because
ridiculous. Because
then
what
you
if I get
forget
it
to do
wrong?
it. Yeah, or
You
get it
forget
wrong.
it, you copy and paste incorrectly, whatever, and it's just dumb.
Yeah, it's very easy to forget, right? We've all been there, I think, right? You have lots of methods, right? And you repeat the same validation logic in all the methods, and sometimes you forget about that in one method, and that's because the compiler is not helping you at all, right? You have just strings, and you can't do the compiler doesn't know anything else about your strings, right? It just know they are strings, so
a string is a
it
string.
can't help you, right? So the idea of this is making the Scala compiler work for us, right? So use the incredible power that the Scala compiler has, right? Because other languages, other compilers don't have that power, right?
True.
But Scala does, so we should use it.
We should use it. Awesome. Well, this is such amazing work, and thank you for sharing it with us, Jorge, and thanks for joining us on the podcast. Super fun to see you. Hopefully we can see you in person sometime soon.
Yeah, I hope maybe next functional Scala. And yeah, well, it's been a pleasure for me also having this time with you guys to discuss about smart types and my beginnings with Scala as well. So yeah, thank you a lot for inviting me here.
Really interesting.
Thanks.